I'd like to thank Professor Sunil Kumar for inviting me to be with you on your birthday. Wish all the Institute a very happy birthday. I'd also like to thank Dr. Anand for helping me with the logistics. And also, I'd like to thank Sri Venkateshwaran for his very kind remarks. Uh, what I'd really like to do is to talk to you a little bit generally. I'm going to talk about engineering and science, but I will begin by showing you what has dominated the entire year of 2020, and probably a good part of 2021. The coronavirus is a public health nightmare. It's also an artist's delight. So you can see on the internet many, many pictures of the coronavirus. A definition of a virus is given in Peter Medawar's famous book From Aristotle to Zeus, which is a dictionary of biology. But I know that biology is not a subject which is currently being taught at IIT Palka, but it must be a subject which is taught sometime in the future because biology really dominates our lives. One thing that the coronavirus has taught us is this, that before biology, both politics and religion retreat. The only answer to the coronavirus now will come from science. And even today's work on vaccines is really what has happened over the last 8 months or so, where frantic efforts have been made to develop a vaccine. What does biology really deal with? In fact, biology deals with this, physics deals with it, chemistry also deals with it. We worry about nature. In fact, all of science is really an understanding of nature. How do you define nature? I have taken the definition of nature from the most famous journal in science. The title of that journal is Nature. It appeared in 1869. And in volume 1, issue number 1 of Nature, there was an editorial. This editorial was written by the famous biologist Thomas Huxley. What Huxley did was he didn't write anything. He merely quoted, he translated from the German poet Johann Goethe, who describes nature. He says we are surrounded and embraced by her, powerless to separate ourselves from her and powerless to penetrate beyond her. Nature is all around us. And science helps us now to understand nature. But in the IITs, and I was a student in the IIT, I probably joined IIT Kanpur, that was roughly a little over 53 years ago, when IIT Kanpur was as young as IIT Palakkad is today. And so I know what science is, what engineering is, and for almost a decade, I was the director of the Indian Institute of Science. The only quality that distinguishes the Indian Institute of Science from the IITs is that in the Indian Institute of Science, there are as many engineers as there are scientists. So in fact, sometimes it would appear that it's an institution dominated by science, but it's almost evenly split between science and engineering. We always think of engineers as innovators. I've taken 2 definitions of engineering, because some of you would be young faculty, the others might be young students. Both are from famous engineers. Petrosky said that often considered distinct, engineering and science are frequently difficult to do. This is true when you get to the research level. In fact, most engineers doing research at the Indian Institute of Science, to my mind, they were actually only scientists. Von Karman said that the scientist seeks to understand what is, the engineer seeks to create what never was. This is another definition. An engineer, for example, might create an aeroplane. But if you think about it a little bit, you will find today even biology might be creating new things. Chemistry is creating new things all the time in the form of new materials. So this definition is also a somewhat outdated definition, and you must think about this. We would like science to be useful, and in the public imagination, pure science translates into applied science, which goes to engineering and eventually to technology. This is an unrealistic linear sequence, which is never really going to happen in real life. Vannevar Bush, in his very famous report, which really kicked off American science after the Second World War in 1946, he said that science by itself provides no panacea for individual social and economic ills. If Bush had been alive today, he would agree that science is the only thing which is likely to provide an answer to the coronavirus. He says it can be effective in national welfare, but only as a member of a team. But without scientific progress, no amount of achievement in other directions can ensure our health, prosperity, and security. This was written in 1946. The day before yesterday, after the new American president took office, he has now written another letter which is modeled on Franklin Roosevelt's letter to Vannevar Bush. And very soon you will see that there is a new thrust to American science. I want to discuss three words with you. These are the words discovery, invention, and innovation. We hear about them all the time. I did not hear the word innovation when I was young, but as I grew older, I heard the word innovation very often. Discovery relates to something like penicillin, found by accident, serendipity. Invention is something that you might invent purposefully, like the light bulb of Edison. You can ask, what is relativity? Relativity might be considered an invention of the human mind, but this becomes a somewhat philosophical discussion on whether relativity is a discovery or relativity is an invention. But what is innovation? Innovation could be something as mundane as a retail store, which we've all got used to. It could be something like Amazon. It could be the many, many apps today which dominate our lives. These are now slowly, they're products of science, they're products of engineering, they're products of technology. What are the ways of doing science? I show you an article which appeared last year and about 2 years ago now, called A Science Tool in the Scientific American. I've merely read this article, which is only in words, and illustrated it on this slide by putting a stool there. What are the three legs on which science stands? One is, of course, data. The other is theory to explain the data. And last of all, the ways of communicating it to other people so that science can be more purposefully used in everyday life. On the four corners of this slide, I have indicated four scientists. They're all old scientists. They died a long time ago. Copernicus, who taught us our place in the universe. William Harvey, who was the first person who realized that blood was circulating through the body. Jenner, who gave the first vaccines. And Darwin, of course, who gave us the ideas of evolution on which biology rests. You're in an institution which is going to grow. I was always in an institution which had grown mature. I was fortunate to be the director of the Indian Institute of Science where it celebrated its centenary. So there are two occasions when you celebrate institutions, when you are young and when you're very old. If you reach 100, you celebrate even human beings. What happens in an institution? Research happens in an institution, and there are two kinds of research. There's research which is use-inspired, and there's research which is fundamental research. I've simply illustrated what in the literature is known as Pasteurs Quadrant, introduced by the American political scientist Donald Stokes. He simply divided research space into four quadrants. On the top right quadrant, he put Pasteur. The bottom right quadrant he named after Edison. And the top left quadrant he named after the famous physicist Niels Bohr. Bohr's work on the hydrogen atom may have appeared to have little use, but it set the stage for all the advances which came later in quantum physics. Edison, of course, could have discovered the electron, but instead he purposefully moved towards the light bulb and illuminated our lives. Pasteur, on the other hand, did both basic work. He's the founder of modern stereochemistry, the idea of chirality, the interactions of molecules with plain polarized light, but he's also the man who is considered the father of microbiology and also the man who gave us our understanding of infectious disease. The bottom left quadrant is left unillustrated or unnamed by Donald Stokes. I have simply put it where average academic and industrial R&D really lies, and in order to find an iconic image, I've picked Lakshman's common man. There is no better image to illustrate the common man than Lakshman's cartoon. Most institutions will start in the bottom left quadrant and eventually want to move somewhere. So I've simply now summarized this as academic space, teaching along the x-axis and research along the y-axis. This is the space in which your institutions operate. What is an ideal university or an ideal institution? An ideal institution is where there is a maximum amount of teaching and a maximum amount of research. Best teaching and the best research. Caltech, MIT, Harvard, Cambridge, Oxford. These are the universities which come to our mind every time when we think of famous universities. Some of India's universities were also wonderful in the past. In the 1960s, when I was growing up, all the universities, Madras, Calcutta, Delhi, all of them were wonderful universities. Most institutions rest in the bottom left quadrant, and there must be pathways for directed evolution. I use the word evolution here because evolution is a very, very important word. Individuals evolve, institutions evolve, countries evolve, cultures evolve. Teaching and research are two sides of the same coin. And every institution which aims to be successful must have strong teaching programs and very strong research programs at the same time. If science is to go through engineering to technology, you must realize that science and technology are again two sides of the same coin. We cannot now separate them in any way. I leave you with two questions. Can basic scientific research lead to useful technologies? Definitely so. I won't give you the answer, but I will tell you. The two dominant techniques of today's radiology, X-rays and magnetic resonance imaging, have both come from basic physics. One from Rontgen's discoveries of X-rays over 120 years ago, and the other from the discoveries of Paul Lauterbach in the 1970s. The other question you need to ask, very important, is can new technologies emerge in an environment that does not support science? My answer to this would be an emphatic no. It is important to support science because only then can you get new technologies. And I'm going to end very quickly by showing you something that all of you who are young should think about. What was the world like 200,000 years ago? Today, science has taught us a lot. We know a lot about our past. We know the early history of the earth. We even know the early history of the universe. This is what the world looked like. The patch of gray in the east of Africa is where human beings were beginning to evolve. That is where the first precursors of Homo sapiens, which is the species which we all are, the biological species to which we belong, that is where they came from East Africa. 200,000 years later, by the beginning of the current era, civilization had spread, and this is what it looked like. Nothing was there in the Americas. Nothing was there in Australia. Nothing was there in Russia. But you can see India, China, the Middle East, all of them now have their early civilizations. This is about 2,000 years ago. And the period between 2,000 and 4,000 years ago is what is extraordinarily contentious and very frequently discussed in current discourse in India. So we might ask ourselves the question, is there a connection between history and biology? I direct you to this book, Sapiens. This is written by an Israeli historian, Yuval Harari. But Harari has a better understanding of biology than most biologists. He's a historian. What he says, and I read to you, he says the immense diversity of imagined realities that Sapiens invented and the resulting diversity of behavior patterns are the main components of what we call culture. So what is culture? Culture comes from the evolution of the human brain, and the cognitive revolution is accordingly the point when history declared its independence from biology. When did this happen? This happened about 30,000 years ago with the invention of agriculture. Before the invention of agriculture, there were other inventions. These were technological inventions. The invention of fire, the ability to shape metal, all of these. Before that, human precursors, human beings, were just like animals. They were driven by biology. They were what are called hunter-gatherers who would hunt for food and eat the food. Even today, if you go to the Andaman and Nicobar Islands, you will find the protected tribes are still hunter-gatherers. But Harari goes on to say that if you want to understand the rise of Christianity or the French Revolution, it is not enough to comprehend the interaction of genes, hormones, and organisms. It is necessary to take into account the interaction of ideas, images, and fantasies as well. The rise of cultures is associated also with the rise of religion. But nature is something which goes beyond all of this. Nature was always there before we were there. The Renaissance poet says, "For nature to me was all in all." That's what Mudford says. But I draw your attention to another book that many of you should read. Otherwise, you should look for this on YouTube. The Ascent of Man is based on a BBC series narrated by Jacob Bronowski. And this is one of the best science documentaries ever produced. I'll just read Bronowski here. He says, among the multitude of animals which scamper, fly, burrow, and swim around us, man is the only one who is not locked into his environment. His imagination, his reason, his emotional subtlety, and toughness make it possible for him not to accept the environment, but to change it. And that series of inventions by which man from age to age has remade his environment is a different kind of evolution, not biological, but cultural evolution. What is cultural evolution based on? It is based on advances in science and technology for the last 30,000 years. And he says, I call that brilliant sequence of cultural peaks the ascent of man. When we have so much of what I would call contentious discussion on culture, we must remember that human cultures have evolved thanks to advances in science and technology. Bronowski discusses many things, but I want to read you just one. How do the elements form? They form in the stars. And then he says, matter itself evolves. The word comes from Darwin and biology, but it is the word that changed physics in my lifetime. This is Bronowski over 50 years ago. He talks about the formation of carbon. He says carbon, for instance, is formed in a star when 3 helium nuclei collide at one spot within less than 1/1,000,000 of a millionth of a second. That is 10 to the minus 12 seconds. Every carbon atom in every living creature has been formed by such a wildly improbable collision. It's a beautiful sentence. What does this tell you? This tells you that life itself, biology itself, is a highly improbable event. Yet, all of us are there, all of us confront the coronavirus, and most of us do not appreciate the importance of science and, in general, biology in particular, and the role of physics, chemistry, and technology in shaping modern biology. With these few words, I would like to just wish the institution and all of you a very happy birthday, and thank you very much for letting me join you on this very happy occasion. Thank you.